is the first video you should be watching today over piecewise functions. We'll go through this first page of notes and then look at the project intro, and then followed by the last page of the notes. Please pause the video and rewind as necessary so that you can complete your homework and your project successfully. So a piecewise function is a graph which consists of line segments or pieces of other nonlinear graphs. A piecewise function is defined by one expression for part of its domain and another expression for the remainder of its domain. A great example of when you see piecewise in the real world would be roller coasters. So for this first example, we see that there is a linear function and a quadratic function. What we're going to do is come up with the equations for each and then restrict their domain. So I'm going to start by looking at this linear function. To come up with the equation of a linear function, just a reminder, linear functions are in the form y equals mx plus b, where b is your y-intercept and m is your slope. So first we start with the y-intercept. On this graph, we cross the y-axis at 3, and then our slope we find, visually we can find it by rise over run. So we go up 2 over 1. We have a slope of 2. And then we fill in the rest of the equation. So the equation of that line is y equals 2x plus 3. Now we need to find the equation for the quadratic function. We're going to base this off of our parent function using transformations. So our parent function is y equals x squared. The transformations include a, which is your vertical stretch and shrink, or your reflection across the x-axis, x minus h squared plus k. And just a reminder, your h is your horizontal shift, whereas k is your vertical shift. Also, hk is the vertex. So we can look at it transformation-wise. We're moving right 6, up 5. So our vertex is at 6, 5. That means h is 6 and k is 5. So this equation would be y equals a times x minus 6 squared plus 5. To find the a value, we need to think about the parent function. Normally, we go over 1, up 1, over 2, up 4, because 1 squared is 1, 2 squared is 4. If we look at this function, from the vertex, if I go over 1, I go up 1, over 2, up 4. So this looks like the a value is going to follow that exact same pattern of the parent function. So our a is just a 1. So our final equation here is y equals x minus 6 squared plus 5. Now I have my linear equation and my quadratic equation. We're going to look at the domain for each of these. The linear function, notice, starts when x is negative 2. It then goes all the way until x is somewhere between 3 and 4. Whenever we do piecewise, we use inequality notation, and that's exactly what you'll be doing on your project as well. So for the linear function, we will write this as negative 2 is less than or equal to x, which is less than about, let's say, 3.6. That doesn't have to be exact. It's somewhere between 3 and 4. Then our quadratic picks back up where the linear dropped off at 3.6, which is less than or equal to x, which is less than infinity. So we are still going to assume that this goes on forever on the right side unless we see a hard stopping point. Now, with piecewise functions, we only want to include this 3.6 in one of our functions. So one of them will have a less than or equal to, whereas the other one has just a less than. And you'll see it both ways. So to write this as a piecewise function, we're going to combine the information. And we're going to see it written like this with f of x equals and a brace. So we'll write in our linear equation. Since it has f of x already, you don't need the y equals. 2x plus 3 is the linear function. We'll then use a semicolon to separate our domain restriction, which is -2 is less than or equal to x, which is less than 3.6. Then we can write in our quadratic function, which is x minus 6 squared plus 5. A semicolon with our domain restriction. 3.6 is less than or equal to x, which is less than infinity. So this is the piecewise function that corresponds with that graph. Let's look at the first example together. I want you to pause the video and write in your equation for the linear function and then the equation for the quadratic function. So your linear should have been y equals -1/2 x minus 1. Your quadratic should have been y equals -x minus 6 squared plus 1. Now we can write them in with the domain restrictions. And then you're finished. You can move on to practice problem 2. I'd like you to pause the video, do this one on your own, and then check with the answer. You can look at this as one linear function and one absolute value function, or as 3 individual linear functions. Check your answer with what I've got for my piecewise problem. If you did the 3 linear functions, yours will look a little bit different. You may now go on to the video about the project.